Okay, so good evening, everybody, and welcome to our 2021 series of reliability webinars. My name is Jim Kelly. I'm the chair of META Asset Management Society of Engineers Ireland, and this is our fifth META Asset Management webinar of 2021. First of all, I'd like to say thank you to everybody for attending this evening on this sunny evening in spring. And what I'd like to do is talk to you a little bit about tonight's talk, which is going to be given by Gary Ingram of Emerson and also by Chloe Curry of Emerson as well. And tonight's webinar is entitled Reliability and Maintenance in a Digital World, okay? And what this is going to be about is, I suppose, as manufacturing plants cope with rising complexity, increased costs and regulation, more manufacturers are looking at Industry 4 as a solution. Wireless technology is not only the enabler on which digital plants are built, but from the ground up permits increased visibility of asset health, a mobile workforce in the working from home world, safety mustering and location awareness of site personnel. So we're delighted to welcome Gary Ingram, who's all the way from Scotland, just south of Aberdeen this evening. Gary is sales manager with Emerson UK and Ireland in their reliability and plant web solutions. Gary is an experienced sales manager with a wide knowledge in the electrical, fire and gas and automation industry. He has been with Emerson for 15 years across many parts of their business. He is a long-term member of the Institute of Measurement and Control and an early ambassador of the Emerson Wireless Technology Platform. Currently, Gary is leading Emerson's digital transformation business through the operational certainty model. And he's going to talk to us a little bit about all of those items this evening. I'd also like to mention as well, Chloe Curry, who is a committee member of META Asset Management. She's with Emerson too. She's a field sales specialist based here in Ireland, and she'll be contributing to the presentation as well. So just one point of order as well, if anybody has any questions, if they go down to the Q&A tab at the bottom of their screen and just type them in there, we'll cover those at the end of the presentation. The presentation should take 40 to 45 minutes, and then we should have about 15 minutes for Q&A and for some discussion as well. And with that, I will hand over to Gary. Gary?
Hey, thank you, Jim, and thanks everyone for having us tonight. It's really excited to be talking to you tonight. It's a good group and a good opportunity for us to share what we've been working on over the recent and not so recent past with the wireless technologies and Emerson's plant web digital ecosystem. So as Jim says, I've been with Emerson 15 years now, various roles across most parts of the business. Latest role is around the reliability and plant web solutions, which is the IoT and the digitalization part of the business. So yeah, we'll move on. I've put a brief agenda together. I want to look more at the applications around wireless rather than in depth in the technology itself. If anyone wants to pick up at another time on the technology, we can possibly take that offline. But certainly looking at the applications and where it can benefit the business is going to be key for what I want to cover tonight. Brief agenda, quick introduction and safety moment. Jim's taking care of the introductions. An overview of Emerson. I often think we are a little bit blasé in that everyone knows who we are at Emerson. So I'll give a quick overview of who we are. Then we'll look at the wireless networks or the variety of wireless networks that exist, in particular wireless HART. And then we'll look at the reasons to use wireless against wired. And then we'll look at some of the applications where we've had some real good success stories and customers have seen some real good return on investment. So quickly jump to safety moment, common practice in Emerson and I guess most of your own organizations. So we've just been talking there before the event started about getting back to a more normal way of working, a more normal way of life. And something just to be aware of as the restrictions do ease and open up. is getting back to the tasks we did before and took for granted, like driving. It could be you're a little bit ring rusty, a little bit off the pace. So just when you get back in the car and starting driving, starting getting out again, just make sure, one, the vehicle's up to standard, you're up to standard, and also other road users, they may be a little bit out of driving condition themselves. So just be aware, people may not just be alert and quick to react as they have done in the past. So it takes a little bit of time just to get back to into the norm, even with driving. So that's the safety moment I thought I would cover there today. So a little bit about Emerson. It's quite a busy slide. I don't intend to go through every line. But you can see here we're founded in 1890, HQ St. Louis, the USA, where as of a couple of years ago, we're an $18.4 billion business. You can see the sort of breadth and the amount of employees, manufacturing facilities we've got across the globe. And we're based on two business platforms. Commercial and residential solutions is one, and they deal with freezers, air conditioning units for the large markets, freezers, domestic applications. And then Chloe and myself, we belong to automation solutions, which is the part of the business that looks after the control and automation part of the business. And a little bit about automation solutions on its own. You'll recognize some of the brand names. I guess you see here, there's brands like Fisher, Rosemount, Micromotion through here. And again, Chloe and myself, we belong to this part of the business here, which is around the asset management and the AMS suite software, and also on the plant web part of the business that I mentioned, and that is Emerson's digitalization, or their IIoT part of the business. So Chloe and myself belong here. And this is a list of some of the businesses or the industries that we serve. So I'm sure you'll recognize your own sector in that lot there. So that's just a little introduction to Emerson. If any of you have attended any Emerson event, I'm sure you'll recognize this slide. It's one of our core slides in any material we present. So this is around our plant web digital ecosystem, and this is around the digital transformation of a business. So just to frame really the conversation here, is this L piece shape here, this blue shape piece down the left-hand side. This represents what we call the digital foundation, and this is a traditional way of deploying control and automation systems, where you've got your intelligent field devices, flow meters, pressure transmitters, control valves. And normally you would wire them back to a SCADA, PLC, or control system to carry out the C&I part, the closed loop control. And then you would rely on operators to fine tune the performance and optimize production. It would all be done through the operators. And then after installation, during the life cycle, we'd use traditional sort of service regimes, break fix type regimes, educational services to maintain the system at optimum level. So this is the traditional deployment model here. So what we're looking at here in Plant Web to the right, this digital transformation piece here, this is what we're going to talk about over the next 20 minutes, half hour or so. And it's around, this is where the wireless products sit in this pervasive sensing layer here. And this is, basically, this is a range of instruments or a range of devices, most of which are wirelessly enabled, but it's away from the process control side. This is looking at additional measurements from around the site, things like location awareness here, things like pressure relief valves, lifting emissions, vibration, corrosion and erosion. So this is like the pervasive, this is an additional layer of measurements that allow you to see and hear what is going on around the site and help develop maintenance regimes. This piece here, Chloe's going to touch on this later. With all of this, because there's wireless involved, we always look at the secure architecture, cyber security in the first secure mile, and make sure that there is protection against any systems that are deployed there. And then this next level up around the software, this is an area that we really are developing just now, and most of industry is. There's a lot going on in this space around analytics, machine learning, packages here. And this is where we've got packages to look at the device health, to look at asset health and performance, and then start to look at the data lakes part of it, the big data piece where we start analysing and contextualising data to start delivering some machine learning and artificial intelligence. As a business, we've had to move from being a product and a hardware supplier very much to being more of a consultancy business and consultants and solution architects to start piecing this together. And then this part here is all around the remote monitoring connected service as well, which the wireless part of the business touches on, because once we've wirelessly brought the data into these systems, we can then take that any place across the globe to do the analysis and reporting on these systems there. So the next slide, I apologise for the quality here. I stole this from a recent Emerson event, but it does, for me, it does help put into context where the slide you've just seen, the plant web ecosystem, how we align with the Namur open architecture. And so hopefully a lot of you are familiar with Namur as an organisation. And this is the recommendation around how we bring that data into the machine and operating part of the business. So this, what I like about this graphic is it takes it away from the process control side, because I'm sure you've all experienced where you've seen some really good solutions that are easy to deploy and you can see benefits around the asset maintenance of the business. But the cost and the complexity then comes in because we need to route it through the process control system. And so here we're showing where the pervasive sensing layers come into the asset management software, and then we can bring it into the analytics tools that allow us to make sense of that. So we're sort of circumventing the DCS or the control system. And that's where the Namur open architecture comes in, where it bridges across all levels of the business, from the field devices to the basic automation, manufacturing, up to the enterprise and resource planning layer here. So we use that open architecture structure to get that rich data and take it away from the DCS to where the asset management team can make use of it. And this salmon coloured areas here are where the plant web digital ecosystem aligns with the Namur recommendations. So that's a little overview on plant web, the ecosystem, and how it interfaces with Namur. So now we'll start to look at wireless. So the rest of the presentation is very much themed around the wireless technologies. And over the last 12 years or so, there's been a huge growth in deployment of different technologies around wireless. And you'll see some of the names here on the left that you recognize, names like LoRa, Zigbee, we've got just standard Wi-Fi, 3G, 4G, 5G. And this is the area we're going to focus on in the rest of the presentation, is around wireless HART. So Emerson brought wireless HART to the market around about 12, 13 years ago. And it follows the HART. So if you're familiar with HART in the field devices, it follows the HART Foundation protocols, and it uses these protocols to standardize on the communications there. So what we find is key in deploying or selecting a wireless technology is these 5 points here. The fact that it fits your existing architecture. We don't need to do anything different from what you do day to day in your business. There is often in our industry a need for it to be hazardous area certified. So around ATEX, explosion-proof IS, these sort of areas, there is often a need to have the devices certified for these areas. You want your investment today to be future-proof. You don't want to have to be upgrading what you buy today. You don't want to be ripping it out and replacing it in 6 months or a year's time. So we can demonstrate that as we go through the slides, and we can demonstrate that with wireless HART. Network management is key. We need to make sure the network is efficiently and effectively managed, and that it is optimized to work at all times. And also the deployment of wireless technologies. That is the big advantage around wireless, is the simplicity in deploying the technology. And back to the previous slide, the complexity tends to come in when we've got to route the data through a DCS, which has been the traditional way. But now with some of the new technologies, we can sort of bypass the DCS and make it more agile and easy to deploy. So this is what Wireless HART is all about. I don't know if any of you've been exposed to Wireless HART, if you've any experience in Wireless HART, but it's all around, it's based on the 2.4 gigahertz spectrum. It's open, it's license free, and it has been designed specifically for an industrial environment. We took great care, we knew the environment that this wireless technology had to be deployed in, so we took great care to design it for life in an industrial application. So now you see here along the bottom line here, we've got over 40,000 wireless networks operating globally. It is the biggest or most widely deployed standard out there. And we've got over 14 billion operating hours with Wireless HART. So this is the mesh network. This is how a mesh network forms. It's a self-organizing, self-healing mesh network. And the beauty of it, the self-healing part, if I use this graphic, so here if there was to be an obstruction, you can see how the mesh is formed. Let's say a piece of plant, a temporary structure, a port, a cabin, something comes in the way of the communications between two devices. The system is agile and smart enough to route its way around that obstruction. So this doesn't need an operator intervention to change that. The network itself senses that there's been a break in the communication route and adapts itself to find an next route around it. So this is how the network continually corrects itself and is agile enough to move around the network. So that is the self-organizing and self-healing part. So in the next slide, I've used this is the new wireless vibration monitor. I've used this here to illustrate pretty much the same concept of the mesh network. But you can see here to the left, we've got many outlets for the wireless data. So the gateway itself gathers the data. Then we look at the protocols, 485, serial links, TCP/IP, Modbus. Even now with the partnership with Cisco, we can even offload the wireless data wirelessly. And I'll explain how the difference between the two networks later. But this is the key parts of a wireless network. The self-healing part we touched on, multiple paths, as you can see here. There are many routes for that data from here to get back to the gateway. So the network continually forms and reforms itself to give the most efficient way of communicating. Secure encryption, each device has its unique join key. So every device on the network is configured with its own join key. That join key self-rotates, so it continues to change during the life cycle of the network. So it might be 1, 2, 3 at the moment. In the next 10 minutes, it will be 4, 5, 6. So it continually moves that join key so that it can't be any device that shouldn't be on that network can't join the network. Secure encryption, Chloe will touch a little bit on the security, but there is sort of cyber built into the network. That was key in developing this network. And then we've got the frequency hopping part. So what the gateway does continually is it listens to that network. So the 2.4 gigahertz bandwidth has 16 channels of communication open to it. So it continually listens to that part and to that part of the bandwidth. And if it sees any congestion or any traffic on a particular bandwidth in there that shouldn't be there, it will move up or down the spectrum to find vacant channels. So it's making sure that the communications are optimized across the network. So it's quite an intelligent network. This doesn't need an operator continually viewing and changing and adapting the network. The wireless gateway is the network manager, and that continually optimizes and tunes the network for most efficient use. So the next slide is really putting these graphics onto a live application. So this is one of our network design tools or network management tools. And it kind of illustrates here the range that you can get with the the wireless HART network. Down here, just to give you an idea of scale, these seem to be cars or vehicles in the car park here, but you can see the scale. So here's the wireless gateway here in one of the control rooms. To the left-hand side here, you can see you've got a good, solid mesh network with many paths of communication being developed back here. So you've got a really good network formed here. As you start to reach out to this side of the site, to the right-hand side, you can see there's some weak points in the network. So yes, the network's working, it's functional and it operates, but you can see the communications are all from here are all channeled through two devices, and that is not the best network design. So you'd maybe look at positioning one or two devices around this area, repeaters or pressure gauges, just additional wireless devices, and that would help even the load across this network from here and start to form a more wider mesh. But you can see the distances here, almost be talking a couple hundred meters, I would have thought, across the site, and you can see how the network forms. And this is the network management tool. So any of our systems has this inbuilt. We can look at this and we can see where there is pinch points in the network and where any sort of repeaters or additional equipment is required there. Another area to consider in deployment, and it's a big area for our consideration, was the environment that these networks will be deployed. So rule of thumb, I guess, if you can see the device from the last device, it's a fairly light, populated or dense area. So you can see here the distances. So an open line of sight, we're looking at about 200 meters. In a lightly populated area, we're looking around 150 meters. Medium 75 down to 30 meters. Now these distances are between wireless devices, not from the gateway to the furthest device. So in any sort of environment, 30, 40 meters is in a plant, that's a good sort of distance, a good range here. And you can see the differences here. So a fairly open area would be considered light. This area here, which is like a well bay area, a bit more densely populated, is one of the moderate areas. So you're looking here in the moderate areas, about 75 meters. And then once you get into the heavy areas, which would be right at the bottom of these, look like storage tanks or bullets at the bottom, in that area there, you would be looking to get the distance down to around 30 meters of density. But so some of the feedback we've heard from the early deployments, there was areas in the offshore industry where they just thought wireless wouldn't fit, because anyone that understands an offshore installation, it is highly populated or dense material, blast walls, heavy metal work, and that was some of our very first wireless installations, and they worked without any problem at all. So it is tailored for this environment, but it is something to consider as well, is the density of the environment that will be installed in. So I'm going to let Chloe take the next few slides, which is around the battery. One of the questions that comes up regularly is around battery life. How long do the batteries last? So Chloe's going to take the next few slides, and then I'll come back in at the end.
Yeah, so between the battery life and cyber is where people have an awful lot of questions. So Emerson has actually a really handy tool for helping you estimate the life of your battery or your power module. And I can send a link to anybody that's looking for it, drop me an email. But all you have to do is go on to the link, choose your smart wireless device, set your update rate, which could range from seconds to hours depending on the asset that you're monitoring. And then also the temperature, the average temperature that the device is in then, and it'll give you an estimated power life of the battery itself. So when you actually as well, when you deploy a wireless network, you'll also have the ability to then remotely view the longevity of your battery within the software that comes with your wireless gateway. So you'll be able to tell when a power module needs replacing. And then when you really begin to build up your wireless network of devices and you have more that you're monitoring, we also have an application package within our plant web solutions that'll allow you to build alerts into that as well. meaning you'll be able to receive alerts when, for example, a power module needs changed after, say, 3 months of battery life, which are critical, which are fine as is, you know. So yeah, battery life for sure. Then cybersecurity. Gary, if you just hop on to, thank you. Cybersecurity is another question that's brought up a lot with wireless, because people seem to have this notion that when you go wireless, you're connecting everything to the internet, and it's totally not the case whatsoever. That your wireless HART network is almost like an isolated network on your level 0 of your network architecture. And it was developed with cybersecurity in mind to the IEC 62591 standard as well. If you need more information, if your IT departments maybe are looking for more data on that, I have a really good white paper I can provide if you drop me an email. But Emerson uses a layered approach with cybersecurity, not just with our wireless technology, but with all of our solutions that we can provide. First of all, the data that is transferred throughout the network is encrypted. So if anyone was to intercept the data, it would be completely scrambled information. Second of all, we're able to authenticate the sender and the receiver of the devices that send and receive information, to be able to verify that the data hasn't been changed, that the device that you're speaking to is in fact the device you're talking to, almost like a handshake with exchange of information, along with the use of passwords throughout the entire solution. So you'll need a password to log in to actually log into your gateway, a password to view the data, a password to join a new device to the network, Gary mentioned earlier, as well as the devices having their own internal system of passwords for communicating between each other, or every time that this handshake occurs. And then on top of this, the wireless gateway itself has a built-in firewall for extra added protection. So it's a really strong and secure solution, but we've kept everything really user friendly. The interface is all user friendly for the day-to-day users of the devices and the added software as well. Thank you. And this is just a note to say that again, you touched on it briefly, Gary, that when we deploy these devices on our wireless networks, every device that we add is actually strengthening the network. So we can utilize this one wireless HART network for vibration monitoring, steam chart monitoring, toxic gas monitoring, wherever it may be. They all use the same wireless HART network. And as Gary will touch on it in just a second, it's completely system agnostic, independent of your control system that you use on site. And as well as being designed to cybersecure standards, they're also our wireless gateways, our Cisco wireless access points, as well as all of our wireless devices are certified for hazardous zones, or ATEX certified, so they can be deployed in whatever environment that they need to be deployed in.
Okay, thank you, Chloe. So it's a good overview of the cyber and the battery. It's the two more common questions that come up on any wireless themed presentations is around battery life and cybersecurity. That is the two main questions. But this is it's the last slide before we get onto the applications. And this kind of shows the difference between the two network technologies we touched on. Chloe just showed the combined unit, which shows the Cisco access points in conjunction with the wireless HART wireless gateways. Now, what we're looking at here at the asset level and the field infrastructure, we've got the WiHART, or the wireless HART networks. And to the previous slide that Chloe spoke around, you can see where we've got the pressure, the valve diagnostics. These all sit on the wireless HART networks. So they've got quick update times, battery powered, so you don't need additional power supplies to them. So they all work in their own wireless HART network. Traditionally, we would have taken these gateways and we would have wired them back in to a DCS to take that data. As I keep mentioning this, I know, but it's been one of the bottlenecks in deployment of wireless, is that it goes into the DCS, and they've then got the cost and the complexity of bringing that through the DCS layers to where we can use it. Now with the Cisco overreaching architecture, we can bring this wireless data back into the Cisco network, which is bringing your sort of your business systems out into the industrial plant. So we can start to bring that data in here, along with video, along with remote worker, location awareness. So we've got all this high bandwidth applications now we can bring in. And that allows us to bring these isolated pockets of wireless applications into the main network and bring it back to where the asset management team can start to make use of that data that's gathered. And as I said in an earlier slide, these pervasive sensing devices are to help you hear and see what is going on in the plant. It's looking at acoustic and visual information to bring that back in. And the whole of this here fits back, working backwards, fits into our operational certainty model, which is all around increasing safety, improving reliability, optimizing production, and it also plays on the sustainability card, where we're looking to optimize or minimize emissions and optimize energy usage. So all these pervasive sensing devices bring it back to this operational certainty model. So that brings us to the next question. Why wireless? Why would you use wireless? And the obvious answer is always save wiring on cabling, save money on wiring, save time, less infrastructure, less containment, and an ongoing life cycle of the system. It's less testing and inspection of junction boxes. So there is the obvious benefits there, but I guess the less obvious one, and it's probably become more apparent this last year, the amount and availability of people on site at the moment. We've got to make more of the resource you've got on site, and by bringing some of this data in wirelessly, we can make better use of the people that you've got on site at the moment. So we're looking at operator rounds here, and that typically focuses on like the balance of plant, utility gas, oil level, various routine measurements that are done by operators. You've also got the part here is you're taking people out of the risk area. I mean, putting operators in the field has been a necessity, but it is putting people in harm's way. So if we can reduce that, and here is one of the more simple applications here, where we've got a wireless pressure gauge. So if you want the comfort of looking at a gauge to make sure that it's reading and that the pressure looks about right, you've got that comfort factor. But that pressure gauge also sends a wireless signal to your historian, so you can start trending the pressure measurements, not 2 or 3 times a day. We can do that every minute, every hour, every couple of hours. So we can start bringing that data in more regularly, more consistently. We can bring it in, especially in the vibration measurement. We can be bringing that measurements in from the same point every time, instead of relying on someone being being good and methodical in their data collection routines. So a lot of advantages there. So some of the less obvious reasons for using wireless, and this is where it kind of will bring it all together using wireless. So following this loop round, what we're doing here is we're starting to bring the closed loop control scenario that's been used in the process control environment for a long time. We're now bringing that into the asset management environment by closing the loop here. So we're bringing the data in using these pervasive sensing techniques. So it's a lower cost of deployment, easier to deploy technologies, not necessarily around process control, often around asset management and asset maintenance. We bring that into our data historians, or into the PDM, the predictive maintenance systems or control systems. We've got a small feedback loop in here that we can optimize asset health and performance using this data. But we can also take this into well, not into the cloud necessarily, but into the big data game, where we're starting to look at the data historians and the data lakes, and start to use the analytics platforms to make sense of that data. So we can start to read, and you see here some of the neural maps and the root cause analysis trees we've got here, failure mode trees. You can, by looking at this, you can start to make sense of this data. It can start to, the new analytics platforms can start to say, well, the last time we've seen this happening, you got 6 months before you had a catastrophic failure. So we can start to predict failures and start to take remedial action before, further up the failure curve. This also feeds into things like your ERP systems, your CMS systems, and we can start to automatically generate work orders, notify the maintenance team, check availability of spare parts, so that when the maintenance team go out to perform the remedial action, they're better equipped, they're better informed, can make better use of the time that they are on site, and they're more productive in doing so. Then we continue this loop around again, we continually optimize and improve on the processes, and we just continue this loop, making it more of a closed loop function as opposed to manual data collection and doing the operator on inspection rounds. So this is, we're on the home straight now. I've just got a few examples here of where we have used wireless, where we've deployed it in some applications where people have seen some real benefits here. So the beauty of the wireless technology is it allows us to follow this model. We start small, but think big. So it's scalable. We can start on a small asset or a small part of the plant with a bigger vision, but then it allows us to scale up to meet the bigger demand. So we can, using wireless, we can deploy this for a few tens of thousands of dollars on pumps or corrosion or steam traps. So we don't need to be investing hundreds of thousands to deploy these technologies. We can start small, get the proof of concept, demonstrate a return on investment, because one of the biggest objections we hear to digitalization in general or deploying this wireless technologies is demonstrating a clear return on investment. There's a lot of people like the technology and would like to try it, but it's building the business case that is key to a successful deployment. And this allows you to do this at a small level around these assets. If the proof of concept and return on investment stack up, we can then move it up a notch, and we can start looking at the asset health and performance software packages that exist. So we can start looking at heat exchangers, fans, a lot of other technologies there. And then we can then move it up right into the operational certainty model, where we're starting to link this in to your enterprise resource planning systems and achieving the top quartile system. So it's designed to be fully scalable, start small, think big, and then scale to achieve the goals. And some really easy examples, some really entry-level stuff. This is a fairly common application you see on chemical sites, pharma sites, where the safety showers, eye baths, there is a need to measure or to record how often they are activated, duration of activation, and also on the maintenance of these things. So rather than trying to cable every safety shower or eye bath back to a wired system, we can deploy our 702 discrete input transmitter, and it's a fairly easy win. You can start, you've got a flow switch here, so when it starts flowing, trips a switch, and you get a notification of the activation. That can then be logged, recorded, used as part of your health and safety reporting regime. Another relatively new product, wireless gas detection, we've got here. This one's around hydrogen sulfide. A recent example in the pharma industry we had was on the oxygen deficiency. There was a risk on a pharma site in the UK that it comes back to the operator rounds. Normal operation, the areas were regularly manned. So the people that were in there had the portable gas detectors on their person, and they could start to detect if there was any, it was for nitrogen leakage, so they could start to detect if there was any decrease in the oxygen levels around there. With there been less people on site and these areas being less frequently manned, there was a risk that there was a build-up of nitrogen in the areas depleting the oxygen, and someone would walk into a heavily depleted area. So there needed to be a quick and rapid deployment of gas detection technology or oxygen depletion technology. So we had gateways on site. The company were familiar with the wireless technology. So as Chloe said, these technologies can coexist on the same network. So it was relatively cost effective and relatively quick to deploy the oxygen deficiency gas sensors. And they're continuing to do that. There's some real benefit in that win. So that is another use case for wireless gas detection. Energy, steam. This one here is all around steam traps. The numbers there, we've got some calculators, so if anyone is interested, we can sit down and we can do the calculations based on your costs, your efficiencies, how much you pay for steam, how much you pay for energy. But it's back to the sustainability part. It's a big saving on energy. It's a big energy saver, measuring the performance of steam traps. So it uses this acoustic device to listen for the steam traps being activated. Same device, different application, pressure relief valves. There's a need to, like safety showers, to measure and record emissions to atmosphere of gases. So there's two ways here. We can measure the ruptured disc using the wireless pressure gauge, and we can supplement this with the acoustic measurement, which again is listening for this line becoming active. So when there's a release, this bursts, we start to hear the noise, we see a change in temperature, so it measures the temperature as well, and we can start to measure the time and duration of any relief. So just some general slides now, general applications around heat exchangers, pump performance, fans, cooling units, all done wirelessly. And this is more details. I'm not going to go through each one because we're about there on time. I don't want to hold you back from a nice spring evening getting out for some fresh air. So this is all around pumps. This is the different measurements we make around pumps, differential wireless across the strainers, vibration measurement on the pump itself, seal fluid level, discharge pressures, suction pressures. There's a lot of measurements we do wirelessly there. And this is also supplemented with the algorithms we've got in the analytics packages, which makes this easy to deploy. Heat exchangers starting to move from a time-based maintenance regime to more of a condition-based maintenance regime. So you're only cleaning the tubes and stripping down heat exchangers when the measurements indicate that there has been some fouling or there has been pitting and corrosion in the tubes themselves. So there's and these instruments don't need to be wireless. A lot of the instrumentation will exist for the heat exchanger applications. So it's a case of bringing the wired in with the wireless, using the wireless to supplement what you already have. Heat exchangers, air-cooled heat exchangers, similar applications. We're measuring bearings using the wireless vibration, multiple temperature inputs, louver positions, and that feeds into pre-built analytics packages that help optimize performance and health of these assets. So that's really it. I don't want to dwell on each of the applications. Hopefully it's food for thought. As Jim said earlier, we will share the presentation today on the website that's been recorded. And there's some links here if you need more information. There's the Emerson homepage, there's myself, Chloe, and Gary Lees, who I'm deputising for tonight. Gary's our wireless BDM in the UK and Ireland. So there's some of the contacts or the routes to get more information if you want further information. So other than that, just thanks for your time. Thanks for listening. Hopefully that was of some interest, and happy to take any questions that may have come forward.
Yeah, excellent. Thanks very much, Gary, and Chloe as well. That was a really good overview of wireless technology and wireless instrumentation and control systems as well. So we do have a few questions that are after coming in. First one here is from Ronan Murphy, and he's asking, is there certification for the security of the Wi-Fi network against external interference or hacking?
Yeah, I can take that one. So the actual standard is called IEC 62591, and if you give that a Google or you get a bit of research around that, you'll see plenty of documentation come up. Equally, if you also you can fire me an email or you can just Google Emerson wireless security, and you'll see Emerson's white paper documenting all of these standards and everything that we touched on today, basically in a document.
Okay, very good, thank you. Another question from Ronan as well, one that I was probably going to ask as well. I'm interested to hear, is calibration different for wireless devices? So wireless instruments in the field, is the calibration any different?
It would, in terms of pressure, temperature, the process can do exactly the same. It's exactly the same device. So if you're familiar with the Emerson 3051S as a pressure transmitter or the 3144P, the device is exactly the same. Probably the communications is more akin to a field bus type communication where they're using a digital signal to communicate as opposed to an analog. So you wouldn't, this is one of the big time savers, you won't be tuning an analog loop. We'll be taking a digital signal straight in. So that all adds up to the time saving on commissioning and such like. But the calibration of the device is exactly the same. Go to the same lab, calibrate it the same way, and then just interface it wirelessly as opposed to wired.
And just as a follow-on for that question then, where are we with smart instruments in terms of number one, either auto-correcting and always keeping themselves in calibration, and number two, notifying you when they need to be calibrated? Where is the industry with instrumentation now?
Right, it's maybe more a question for me, some of the Rosemount guys to pick up, but certainly the notification, all our devices have got a degree of intelligence in there that if there's any failures or any what's the word I'm looking, deviation from the standard levels, that's alerted through our device manager software. So if you've got there's diagnostics in the device, so if you've got a deviation from the norm, that is alerted. The calibration regimes, I would need to go to some of the Rosemount guys to get the best answer. I can do that. I'm sure, like everything else, I'm sure we've got a paper or a statement on it.
If we could even as a follow-up, even to that would be very interesting, just because it's something I think everybody wants to know about, because we're all familiar with, you know, instrumentation and calibration, and it hasn't moved on a whole lot in the last 20 or 30 years in terms of how often we calibrate and determining when we calibrate. I know some companies have made vast movements forward, but not everybody. So if there is something out there that you could share, that'd be great.
Yeah, I'll do it. So certainly my last role was in the flow measurement. We did a lot of CBM around ultrasonic meters.
Yeah.
And a lot of it was down to, they would stick with the 6 monthly calibrations until they got the comfort. So they would do a 6 monthly calibration, then they would check that as found, as left, as found. And they would gradually get the comfort that nothing had shifted in 6 months. Let's make it 9 months. Let's make it 12. So there was a step change in the fiscal measurement there. But I'll consult the Rosemount team, and we'll certainly come back to you on the current thinking is around that.
Question here then from John Coleman. Systems like these collect vast amounts of data. How does the system convert the data to useful information for the maintenance technician?
Right. Again, that's maybe another presentation. We've got a lot of the early wireless systems. You're absolutely right. It was just numbers that would come back, and someone had to make sense of these numbers. Use Pi Vision or some of these systems to try and make some form of graphs. We've got a tiered approach on the analytics or the analytics packages now. So the entry level, if you want to call it that, is a Plant Web Insight packages. And again, if we can get you links to that. So Plant Web Insight, and I'll jump back maybe to the heat exchanger presentation, if that maybe shows it. Does that show it at all? No, it doesn't show it too well. But this app here, this is the heat exchanger. We're calling them apps because they're pre-built analytics packages. So the Insight it's custom built. It knows what to look for. So it knows to look for certain differential pressures, certain temperature measurements, the data from the valve. So it looks for that information. It knows how to analyze it, and it gives you some health scores based on that. So that is I want to call it entry-level pre-built analytics packages that we've got. If you step up into our optics platform, where we've got the optics analytics piece, that becomes more custom built. So you can start to bring in other factors in there, like we can start to bring in corrosion and erosion into the equation. We can start to bring in, if you look at maybe some of the heat, not the heat exchangers, but the steam traps and stuff, we can start to bring in energy use and energy calculations, even things like fuel gas costs. So we can start building in a more holistic view of costs and things.
Okay.
So the packages are there. It's just a case of tiering it to what your need is. The simplest form is the insight. You can go right up to the advanced analytics and machine learning level, but the packages are there. And I could send through information on that if you want to share it with the group.
Yeah, there's just a question on steam traps from John Byrne. Can you add the acoustic device to existing steam traps, or do you need to replace the traps? And similarly, can you add wireless add-ons to convert existing instruments to connect to the network, or do you need to have a wireless instrument to start with?
The answer there is yes to both. We can. I'll just get the graphics. So the acoustic device there it's listening. It's a piezo sensor with a built-in temperature device as well. So it's looking for a change in temperature, and it's looking for the noise. So it's listening for the steam trap, the acoustics around the steam trap. So it literally bolts on the way you see it there, using a say spiral band, Jubilee clips almost to clip that to the pipework. In terms of retrofitting existing devices, the early days of wireless, it was all around the device, AMS device manager, and using that data. But there was a lot of the diagnostics were stranded with old style barriers that weren't allowing the heart pass through. It wasn't allowing the heart data to pass through. So they developed, it might actually be in one of these slides, the thumb is the device we call it. It might be in one of Chloe's slides.
I think I've seen it in there somewhere.
This is the thumb here. So thumb,
okay.
It's not a misspelling. It's called the Heart Upgrade Module. Is what thumb stands for. So basically that screws into any wired device that is version Heart 7, or I think it's Heart 7 or above. That lifts the heart data from that device. So if you've got wired infrastructure there, but you can't get the data into your asset management system, the thumb screws into the wired device, lifts the heart data along with the diagnostics, and sends that back to the wireless gateway. And then you can then pick that up in any of the analytics tools that we've got available.
Okay,
so,
very good, very good.
Real easy to retrofit, yeah.
Yeah. Kieran Finnerty has a question just on the heat exchanger monitoring that you were showing there. Would you expect, or have you seen any cases where statutory inspectors would accept wireless continuous monitoring as an acceptable form of maintenance, as opposed to the statutory inspections every 14 months or 26 months?
Not yet. The Insight package is relatively new. It's only been released probably 3 years tops, 2.5 years. And I guess it's back to the same analogy I gave on the flow measurement, using the CBM, the condition-based maintenance regime on the flow measurement. They would watch it, analyze it, continue to do the time-based calibrations, and just look and see what shift there had been as they got more confident. So I would have thought in the next 2 to 3 years, as they get the confidence that the Insight packages are reliable, they would start to see that shift from a time-based to a more condition-based regime. I think it's too early yet for them just to. What we have got is we've got seen a lot of support and a lot of interest from one of the major heat exchanger manufacturers who are running their own trials. And they've really adopted this. They've put it on a couple of pilot schemes, not in the UK, I'm afraid. It's Middle East have done their pilots. But they are measuring that because they want to add it to their service regime. They want to offer it as a service that they can start adding that. So yeah, there's a lot of interest in that. It's a big saver if it's proven to be reliable.
Okay. Shane O'Neill has a question here. In terms of pharma and clean rooms, does the panel need to be close by to bring the signal back to the AMS? You know, in situations where you have lots of smaller rooms, is there any way around having lots of repeaters, or can they beam through these walls that in clean rooms?
I need to see the gateway itself is mounted remotely. I'm trying to think of the application. Each device is a repeater, so each it's not like we don't need a powered repeater. So probably the lowest cost way of introducing a repeater is to put in a wireless pressure gauge. That will act as a repeater, and it'll give you, if you want an additional pressure measurement, or in a clean room application, maybe use one of the discretes. You might want to measure a door being closed or a door being open. You can feed that into the discrete, and that acts as a repeater. We'd really need to look at the application for that. And we need to see the environment of a clean room. If there's a lot of steel construction and the clean room itself is like a steel box, then it acts as a Faraday cage. There's no getting away from that. You would need to take.
Yeah.
So it's a case of looking at the application. There isn't an easy answer, but other than each device acts as a repeater in its own. So.
Okay. Another question here from Niall Owens. Is there a software interface to analyze the data like Pi Historian?
That's where likes of Insight and the optics packages come in. Yeah, we've got some pre-built tools to do that. If you want to take it straight into Pi, absolutely. That's the early days of wireless. That's exactly any of the early wireless adopters. That's what they did. They brought it straight into Pi Historian, used Pi Vision to create their own trends and graphics and performance data from that. So yeah, it's the communication protocols are pretty much industry standard. It's Modbus, TCP/IP communication protocols.
Okay, very good. Okay, well, listen, that's all the questions for now, and I think we can call a close to tonight's webinar. I just want to say a few final words before we finish up. First of all, to thank Gary and Chloe for coming along tonight and presenting and sharing all this really good information with us. And thank you to Emerson as well for allowing them to come and show us this information.